All right, this is Mr. Gilman. Today we're going to start learning about triangles, and we're going to connect that to proportions here soon. But first, before we start messing with proportions and things of that nature, we need to learn a little bit more about triangles. Okay, so what we're going to do is we're going to identify triangles based on side length and angle measure. So we have some triangle classifications, okay, and that just means what type of triangle is it. And you may have learned about some of these in previous classes or in previous grades, but it's good to review it. And just going to get more and more detailed as we go. It says every triangle can be classified by both its angles and its sides, or its sides and its angles. All right, can be classified by its sides and angles. So triangle should have up to two names, or at least two names, depending on what the sides look like, depending on what the angles look like. The sides are the ones that are really hard to remember. Okay, a scalene triangle is a triangle that has all different side lengths. Okay, if we're talking about sides, it has all different side lengths. So I can draw a little triangle here. That would be a scalene triangle. Each side length is different. Okay, this could be a scalene triangle if each side is different. All right, and then you see that me making those dashes on there. I'm going to talk about that again later. An isosceles triangle has two sides with the same length. Two sides with the same length. Okay, and so I'm going to draw a couple isosceles triangles here for you. There's one. There's one. Isosceles triangles have two sides with the same length. And finally, an equilateral triangle. This one's pretty easy to remember because it looks like it has the word equal in it. And an equilateral triangle has three sides with the same length. Okay, or I could even say instead of three sides, all sides have the same length, so it look like this. Now you may be noticing that I am making dashes on them, and that's because whenever I'm talking about side lengths of a triangle, the number of dashes on each side tells you which ones it's equal to. So like for my isosceles triangle, if I know that two sides are equal, the two sides are equal, I would put a dash on. I would know those are the two sides I'm talking about. Put a little dash or a tick mark on those sides, I would know those two are the two equal sides of my isosceles triangle. Okay, so those little dashes are going to be important. So we have a scalene where all the lengths are different, an isosceles triangle that has two sides that are the same, and an equilateral triangle with all three sides are exactly the same length. We also have a classification by angles. All right. If it's an acute triangle, it will have three acute angles, or three angles less than 90 degrees. Okay. So an acute triangle, if you look at it, should have all. Ooh, that one's not probably an acute triangle. I should have all acute angles in it. So there would be one. That's less than 90, that's less than 90, that's less than 90. So it would be an acute triangle. Okay, so on the left we're classifying by sides. There's certain ways we would describe a triangle. And now we're also classifying by angles. A right triangle would have a right angle. Has one right angle and two acute angles. Okay, so we signify the right angle with the little box looking thing, and it tells you that it's 90 degrees. Okay, an obtuse triangle has one obtuse angle and two acute angles. All right, so what you can see is all of them have acute angles. Okay, if there's only two acute angles, it's either a right triangle if it has a 90-degree angle, or an obtuse triangle if it has an angle that's bigger than 90 degrees. And I'm sure you've learned about these a little bit in the past. So we have two different types of classifications. We have scalene, isosceles, equilateral. All sides are different. Two sides are the same. Three sides are the same. And we have acute, right, and obtuse, and these describe the angles. 3 acute angles, 1 right angle, 1 obtuse angle. Okay, so let's take a look here and start classifying these. It says if a triangle is equilateral, it is also equiangular. Might be a new word for you, equiangular. Equiangular, E-Q-U-I-A-N-G-U-L-A-R. Okay, and each angle would measure 60 degrees. I didn't know if you knew this guy yet or not, guys, but all triangles, and you need to write this on your paper somewhere, all triangles angle measures add up to 180 degrees. So it would make sense that if all the angles are equal, then we would divide that 180 into 60 equal parts, or 3 equal parts, each being 60 degrees. All right, and once again, you see these little tick marks on the side of my triangle here, this little diagram. Since each of them has 1 tick mark, that tells me that each side is the same length. If 2 of them had 1 tick mark and 1 had 2 tick marks, let's just pretend I had this triangle and I had 1 tick mark there, 1 tick mark there, but this one had 2 tick marks, I would know that only these sides are the same distance, and this side is a different distance than the other 2. Otherwise, it would also have only 1 tick mark or tally mark. Okay, so congruent or equal side lengths, congruent, equal sides have a tally mark on them. Congruent sides are identified with what looks like parentheses. Okay, so if I put 1 there, 1 there, 1 there, I would know that those are all the same angle. If I had 1 here and 1 here, those angles would be the same, but you know what? If I had 1 here and 1 here, those angles would be the same, but if I had 2 here, I would know that this angle is different than these with just 1 mark on them. Okay, so these little arcs, these parenthesis marks, okay, if it has just 1 and this just has 1, these angles are congruent. If it had 2 on it, then I know that this angle is different than either of these angles. All right. So let's take a look at this triangle classification practice, and we should be able to classify this triangle with 2 different names. One name for the side lengths and one name for the types of angles. Okay, what I notice about this triangle right away is that there are tick marks on it. There's 1 tick mark on each of these sides. That means that this side highlighted in blue and this side highlighted in blue are actually the same length. So if I think about which triangle, and you can look on your chart, I'm not going to go back, but you can look at it, and I think it's on the front side of your notes there. If there is 2 sides that are equal, same distance, then I know it is an isosceles triangle. So I'm going to start with saying isosceles triangle. All right, that's how I would classify it by side. I would just look at the side lengths. The angle measures are also going to tell me a classification. Okay, so I can also classify it by angle. I see 2 acute angles and 1 right angle. So that tells me I must have a right triangle. If I see a right angle, it is a right triangle. 90 degrees is a right angle. Okay. Take a look at another one here. It says classify the sides and angles. So my sides and angles, there's names for each thing depending on what I'm classifying it by. Again, I see that this diagram has 1 tally here and 1 tally here. See how there's no tallies here on this bottom side? That means that it is not the same length as the ones with 1 tally mark on it, or 1 tick mark. Okay, so again, I see that there's 2 congruent sides. If there are 2 sides that are equal and not 3, then we call it an isosceles triangle. Looking at the angles here, I see 2 acute angles and 1 obtuse angle greater than 90 degrees. That tells me it must be an obtuse triangle. And finally, when I look at this last diagram, I don't see any indication on the side lengths of any of these sides. There's no markings that say, okay, this is 1, this is 2, and this is 3. I could mark it like that because if this guy's a 1 and this guy's a 2 and this guy's a 3 tally mark, that means they're all different lengths. If they don't have any markings at all, it just means that none of the sides are equal. So in that case, if I'm classifying by side length, I know that if none of the sides are equal, it is a scalene triangle. I can also classify by the angles. As I look at the angles, I see that 1 is acute, 2 is acute, 3 is acute. Right now I have 3 acute angles. There's no right angle, there's no obtuse angle, therefore it must be an acute triangle because it has 3 acute angles. All right, so hopefully that's a good reminder of your classification of triangles. There's 2 ways to do it. You should have 2 names on your paper today if it asks you to classify it both ways. You should have a name for the sides, scalene, isosceles, equilateral, or you should have a name for the angles, acute, right, and obtuse. All right, and that's it for today.